Hello, hi guys. So today's concept is going to be about, as we can see, rational numbers. This lecture is for class 7 ICSE student who wants to get a gist of the chapter that is going to be taught by one scholar. Okay, in the topic of rational numbers. Okay, before starting off with this chapter, I would like to express like rational numbers are something that should be expressed in P by Q format. Everything, whatever we are going to be discussing in this class, I'll be writing it down. We'll be doing sums, we'll be doing all the conceptual portions. Okay, and make sure to watch this video well. Try to do the sums that I am doing on the board in on your copy so that you get an all-around idea what the particular lecture is about. Okay. Let's begin. Okay, so see, where do we find rational numbers? Okay, let's begin. See, rational numbers, before going off a rational number, let us take a white page. Let us find out what are the different numbers that are present. Okay, like in case we forgot what are the different types of numbers that are present, let me take you back to the very basics. Okay, chalo. So firstly there comes nothing but what we call as natural numbers. Natural numbers. Okay, natural number starts from the number 1 and goes to positive infinity. Okay, when we add nothing but 0 with natural number, it becomes what do we known as the whole number. So this particular part is known as whole number. Now, if we add -1, -2 to minus infinity, we get this entire thing. Okay, this entire thing is what is known as integers. Okay, so if I say what is 1, 1 is a natural number, 1 is a whole number, 1 is an integer. If I say what is -2, -2 is only a negative integer. Okay, what do we say what is 0? 0 is both a whole number and a natural number. What do we say 3 is? 3 is only a natural number. That is the definition of this. Why did I come back to this concept? Because we will be needing the concept of integers in rational numbers. Okay, now as we have done what are the basic numbers, let's shift to our chapter. Okay, see, rational numbers are numbers that are represented in P by Q format. P by Q format. Okay, now this P and Q are variables in which P and Q are integers. But there is a condition. Q will not be equal to 0. Okay, that means denominator should not be equal to 0. Okay, so if it is equal to 0, for example, first let us take two random integers. We are taking 2 and 7. 2 by 7. 2 by 7 rational number? Yes, it's a rational number. If I say -2 by 7, is it rational number? Yes, it is a rational number. But if I say 7 by 0, is it rational number? No, it is not, because 7 divided by 0 will give us an undefined number. Undefined. Okay, what is the difference between 0 by 7 and 7 by 0? 0 by 7 will give us 0. 7 by 0 will give us undefined, or something that is non-existent. Okay, similarly, if I write in the place of 7, if I write 4, 2, 3, -9999, any number, but the denominator is 0, it will still be undefined. Similarly, here if I write in denominator 7, 99, 792, everything 0 divided by any number will give us 0 only. Okay, so this is the reason why now the definition of rational numbers are expressed in the P by Q format, where P and Q both are integers, but the denominator Q is never equal to 0. That's it. That is what is rational numbers. Chalo. Now, can we see how it is represented in the picture? half of teaspoon. We always say no when we are going out in coffee for coffee and something, when our mom makes tea or we make tea for ourselves, we say, okay, I like, how much tea, how much sugar do you want to take? And we'll be like, I want half a tablespoon of sugar. So half a tablespoon of sugar is nothing but, if the entire spoon, if the entire spoon is the one part, so I want half part. So 1 and 2 both are what? Both are integers, and 2 is not equal to 0. So this half is nothing but a rational number. Okay. Rational numbers are fractions are something that is more or less the same. Okay. So fractions we have numerator and denominator. Rational numbers we also have numerators and denominators. But numerator and denominator are nothing but, in this case, integers. Okay. As simple as that. Don't mix them up. They're more or less same, but they have different entities. Okay. So 3/4 cup of a flour. So if I take, see in this particular picture, this is entire thing is of a particular constant. See, 16, 12, 8, 4. So it is showing 2/3, 1.5 third, 1/3, 2. Okay. This is what the quantity is all about. Okay. So in order to measure quantities, we use 3/4 cup of flour, half a tablespoon of uh, sugar, like that. Next comes some more examples. See, in this case of 3/4 meter length of wood. Okay. So if the length of this wood is something that is very long, so if I say this is the length of the wood, this is about 10 meters long. 10 meters long. And the width of this is 3/4 of a meter. So what is 3/4? 3/4 is nothing but 0.75 meters, right? So this is converting this particular decimal into a fraction. Okay. And as this is a fraction, okay, this is also a rational number. Okay, are we clear? Sure. Next, moving on, we have a video on what are rational numbers. I've already explained it to you, but since we are here, we need to watch the video to make it like comprehensive understanding of what we are going to learn. Okay, let's begin. What are rational numbers? See, there are many videos about rational numbers you can see there. So if there are some videos which I can omit to make the lecture more crisp and nice, okay, so I'll be doing that. Okay, but if you want me to show all the videos, do please let me know, so that from the next lecture I'll be showing you all the videos. So firstly, what are rational numbers?
All of us know what a number line is, and the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1/3, 5/6, or -7/12? Each of these are numbers. We don't use them as often as we use counting numbers. Such numbers are called rational numbers. We need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p by q, one number in the numerator and one in the denominator. But there are a few conditions we need to know. P and q should be integers. We can have only integers in place of p and q. And there is another important condition. Q should not be equal to 0. Why do we have a second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what would give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. It is a number of the form p by q, where p and q are integers, and q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the 2. But what if you're asked to compare numbers like 6 by 7 and 13 by 15? How would you find out which one is greater? Don't worry about it. All these questions will be answered in our videos on rational numbers.
Okay, guys. So, basic of rational numbers done. Now, let's come to the chapter. So, if a and b are two integers, and then each a plus b, a minus b, a into b is also an integer. So, this is the basic property of an integer. Okay, let us take two numbers here. The two numbers here, let's take random numbers. Okay, so I'm taking a as 2 and b as 7, anything. So a plus b, 2 plus 7, so a plus b gives us 9, that is an integer. A minus b gives us minus 5, that is an integer. A into b gives us 14, that is an integer. Okay, and it is not necessary that a divided by b or b divided by a is also an integer. So a divided by b, in this particular, it's 2 by 7. Okay, b divided by a is 7 by 2. In this case it is an integer. But if I write here in place of a 0, and now we divide it by a divided by b, so 0 by 7 or 7 by 0 in case of b divided by a will be undefined. So in this particular regard, it is saying that addition, subtraction, multiplication will give us integers only. Okay, but division, as 0 can come in the denominator, that is the reason why it might not be an integer. I hope you understand that. Okay. Now, if P and Q are two co-prime integers, okay. Now, let us see what is co-prime. Co-prime numbers are numbers, two numbers that have no common factors among them. Let me give you an example. For example, if I write 5 and 10, okay, the factors of 5 are nothing but 1 and 5. The factors of 10 are 1, 5, 10. Okay, so in the number 10 contains the factors of 5. Okay, so these two numbers are not co-prime. Okay, now if I write 2 and 3, no common factors between them. Okay, see, we are not going to take 1 as a factor because 1 is a factor of every number there is present. Okay, so 1 we are not taking into account. So in 2 and 3 there are no common factors between them, so 2 and 3 are what? Co-prime. Let's take a bigger number. Let's take 17 and 19. Okay, now this is also co-prime. Now, there is one more thing known as twin coprime number. What is that? Twin coprime means number that is next to each other. Okay, prime numbers that are next to each other, which are coprime. Okay, this concept is not required right now, but just give it, like, hear it, what am I saying, that is it. Okay, so let us take one more number, 2 and, for example, 9. Okay, 2 and 9 have no common factors between them. So 2 and 9 are also co-prime. Okay. Chalo. Now, rational numbers in standardized form. Okay. Rational number m by n is in standardized form if n is positive and m and n only has 1 as their common factor. Okay. Simple. In fractions, we have done simplest form. In fraction simplest form, that is exactly what is the standard form in case of a rational number, simplest form. Okay, let's give it short with examples. If I write here minus 17 by 34, okay, this number is equal to minus 17 by 17 into 2. 17 and 17 cancels out, so this is minus 1 by 2. Now this is the rational number and this is the standardized rational number, the standard form. Okay, simplest form is nothing but the standard form. That's it, nothing else to remember. Okay, chalo. Now let us do some sums. Write down rational numbers whose numerator is the largest number of two digits. So largest number of two digit largest number is nothing but 99. Okay, and denominator is smallest number of four digits. Smallest number of four digits is 1000. Done with the answer. First one done. Second one, write the numerator each of the following numbers. There you, it is very easy, guys. Okay, first one numerator minus 125. Second one 37. See, in denominator minus sign is given, so the answer will be just 37. Third one minus 85. Fourth one 2. See, 2 is nothing but 2 by 1. We have learned that in fractions, right? This is going to be 2. 0, 0 by 1. Again, the answer is 0. Okay. Now, denominator minus 15, 29, 4, minus 7 by 1. So, the answer is 1 here. 0 by 1, again 1 here. Okay. I hope you understood. Now, next, this is the solutions. You can pause the screen and see whether your solutions are correct or not. Now let us find x. Okay, see, these numbers are very easy. Okay, first I will do the first one in the proper way that is possible. So crisscross multiplication. Okay, so minus 2x is equal to 6 into 3. So x is equal to 6 into 3 by minus 2, 3. So x is minus 9. Okay, from the second one I'll be doing it directly. See, minus 4 minus 8 both are denominator, so this cancel 2, so x is nothing but minus 14. Third one 7 35 5, the value of x is minus 15. Third one 6, and this, what is this, what is this? Okay, 3s are 2s are 3, 24, 8, so x is minus 8. 12, so x is 12. Last one minus 3, so x is equal to minus 3. Okay, as simple and easy as this. First one. Okay, now represent rational numbers on the same number line. Okay, see, firstly what we have to do is understand what this representation is all about. We have already done represented number lines in case of integers. Integer representation number lines is already done, so let's find it out for this one. See, there is a number line present here. It has minus 3, minus 2, minus 1, 0, 1, 2, 3. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Now what do we have to find out? Minus 3 by 2. Minus 3 by 2, what, it is minus sign and 3 by 2 is present, right? So how do we understand between which two numbers it is? Okay, let's understand how. So see, 3 by 2, if we want to convert it into decimals, we are getting what? 1.15, something like that. Okay, so 2 divided by 3, we're getting 1210.5. So 1.5 we are getting here. So 1.5 is between what? This is minus, right? So between minus 1 and minus 2, there we go with the answer. Okay, similarly minus half. Minus half is between 0 and minus 1. Okay, half between 0 and plus 1. 3 by 2 between 1 and 2. 5 by 2 is nothing but 2.5, right? So 2.5 between 2 and 3. This is how we represent it on a number line. No, not at all difficult. Okay, you can rewatch this particular section if you have any doubts or issues. Okay, so every positive rational numbers is greater than 0 and every than every negative number. Okay, so let us not spend time on this. Let me give you one or two examples so that we can find out. Okay, see, so if I have a number 0, okay, 0 is going to be greater than minus 1, which is greater than minus 2. Okay, In the number line, if we draw a number line of integers, and this is the 0 midpoint, and here it is -1, -2, -3. Here it is +1, +2, +3. Okay, in this particular range, 3 is greater than 2, is greater than 1, is greater than 0, greater than -1, greater than -2, greater than -3. Okay, so in case of positive numbers, okay, the greater the digit, the more greater the number is. So 99 is greater than 98. But in negative numbers, the lesser the number, the greater the number is. Means -98 is greater than -99. Okay, that is what I wanted to say. Okay, here -1 is greater than -2. Okay, as it is coming before -2. Okay, so any negative number that is closer to 0 will be greater. That's it. Let's now go into this sum. Compare 5 by 7 and -3 by 5. Okay, see, don't have to solve anything. Minus sign is present. Okay, the 5 by 7 is greater. Why do we have to see so many things? Okay, so minus is present, right? So 5 by 7 is greater than -3 by 5. If I write here, if this particular sum would have been -5 by 7 and -3 by 5, okay, then what we will do? We will make the denominators as same. Denominator has to be same. Okay, so we are multiplying the left hand side wala into 5 into 5. Here multiplying it with 7 into 7. We are getting the numbers as -25 by 35 and -21 by 35. In case of negative, the smaller number is greater. So -21 by 35 is greater than -25 by 35. But actually these numbers were nothing but what? -3 by 7 is greater than -5 by 7. Okay, this is how we compare in case of negative numbers, negative rational numbers. I hope you understood. Chalo. Already done. Okay, in this particular case there is no there is no positive sign, there is no negative sign, right? So same thing, into 7 into 7 into 5 into 5, so 21 by 35, 25 by 35. So 25 is greater, right? So 25 is greater, that means 5 by 7 is greater than 3 by 5. That's it. Chalo. Next, done. All the things are the same. Same thing. Upon cross multiplying, we get the same thing. That is what is asked here. Okay. See, this particular method is also true. We can also utilize this. So we have two numbers, 3 by 5 and 5 by 7. So this cross multiplying method is nothing but this and this. Okay, so 21 and 25. So we know 25 is greater, right? So 25 was what here? This was 25. So 5 by 7 is greater than 21. Okay, but I will suggest you do that LCM wala thing, because with that particular method we can do more than two, compare more than two numbers. But in this case, cross multiplying, we can only like compare two numbers at most. Okay, same thing. Now arrange this into rational numbers in ascending order. Ascending order means what? From small to big. Okay, let's do. I have -9 by 10. I have 7 by -8. And I have -3 by 4. First I will do what? I will put this minus side in the numerator. This can be done. Okay. So 7 -7 by 8. Now LCM of these three. So 10, 8 and 4. Okay. So 2, 5, 4, 2, 2, 5, 2, 1, 4, 10, 40. So 40 to LCM. So minus 9 into 4 by 40 minus 7 into 5 by 40 minus 3 into 10 by 40. Okay, so it will become minus 36 by 40 minus 35 by 40 minus 30 by 40. Denominators are the same. Ascending order means what? From smaller to bigger. Okay, smaller to bigger, but negatives are present here. Root negatives are present. So this is the biggest number, this is the biggest number, so the answer will be nothing but minus 3 by 4 is greater than 7 by minus 8 is greater than minus 9 by 10. This is the ascending order. Okay, from smallest to biggest. No, sorry guys, this will just be the reverse. Okay, 36 by 40, that is the smallest number, so this is nothing but 9 by 10, right? So 9 by minus 10 is lesser than 7 by minus 8 is lesser than minus 3 by 4. Okay, that is it. Chalo, move on to the next one. Okay, all done. How do we find rational numbers between two rational numbers? Okay, so rational numbers between two rational numbers. So I've already made you understand this, but let's watch the video. Okay, how do we find rational numbers between two rational numbers? Add, subtract, multiplication. This is not rational numbers or number lines. Hmm, how do you find rational numbers between two rational numbers? Chalo.
Here are the kind of problems that could be asked in your exams. Find four rational numbers between minus 4 by 7 and 1 by 7. Since the denominators are the same, we can easily write the four numbers. We can write them as minus 3 by 7, minus 2 by 7, minus 1 by 7, and 0 by 7, which is 0. We just kept on adding 1 to the numerator. Let me modify the question a bit. You are asked to find 49 rational numbers between minus 4 by 7 and 1 by 7. We just found out 4 rational numbers. How can there be 49 in between? Here's the trick. We can write the first rational number as minus 40 by 70 and the second rational number as 10 by 70. Note that we haven't changed the value of the rational numbers. We have just written equivalent rational numbers. Now is it easy? Yes. On the negative side, we can start with minus 39 by 70, minus 38 by 70, and so on up to minus 1 by 70. That gives us 39 rational numbers in between. We need 10 more. 0 is also a rational number in between. And on the positive side, we can start with 1 by 70 and go on up to 9 by 70. So we found 9 plus 1 plus 39, 49 numbers in between minus 4 by 7 and 1 by 7. They are minus 39 by 70, minus 38 by 70, and so on up to 9 by 70. But here it was simple since the denominators were same. What if they are different? We will see that in the next video.
Okay, let's give this second video same video. Okay, see representations, the rational numbers between this. This is nice. Let's see this.
been asked to find three rational numbers between minus 2 by 5 and 3 by 7. Observe that in this case, the denominators are different, so we cannot directly write three rational numbers in between them. A simpler approach would be to find averages. Averages of these two numbers would be half multiplied by minus 2 by 5 plus 3 by 7. We are adding two numbers and dividing them by 2. After solving this, we get the average as 1 by 70. I will not be focusing too much on the calculations here, as that's not the important part. The important part is understanding the fact that the average of two rational numbers gives us one rational number in between them. Let's say we have a line like this, where this is the midpoint of the segment. If our two numbers are marked here, then the average will be marked here, exactly between them. We have found one rational number between the two numbers, and we need to find two more. It's simple. We just need to find the average of these two numbers and the average of these two numbers. Let's find the average of minus 2 by 5 and 1 by 70 first. It will be half multiplied by minus 2 by 5 plus 1 by 70. We get the average as minus 27 by 140. So we mark it right between minus 2 by 5 and 1 by 70. Next, we can find the average of these two numbers. It will be half multiplied by 1 by 70 plus 3 by 7. This equals 31 by 140. And we mark it here exactly between 1 by 70 and 3 by 7. These are the three rational numbers between our two rational numbers. And if we were asked for more rational numbers in between, we can take the average of these two, or maybe these two, or maybe even these two numbers. Remember, between any two rational numbers, there are infinite rational numbers.
Okay, I hope this particular concept is clear. This was a very important concept that we had to understand. Okay, so finding two rational numbers between any, finding n number of rational numbers between any two given rational numbers. That is what the concept is. Okay, mark the following pairs of rational number on separate number lines. Okay, so I'll be doing some sums here. Let's mark number 5 so that you can do the others and practice it. First thing, we'll draw a number line. Okay, denominator is 4. So let me, it is minus 5 by 4 and 1 by 4. So let me write between 0 and 1 and dividing it into 4 equal parts. So 1, this is minus 1, sorry guys. So 1 part, 2 part, see 1 part, 2 part, 3 part, 4 part. Okay, this is minus 1 by 4, minus 2 by 4, minus 3 by 4, and this is minus 1. Okay, so and in this particular side we're going to write 1 by 4, 2 by 4, 3 by 4, and 1. Okay, so right hand side is positive 1, left hand side is negative 1. So how did I divide? How did I realize that will be 4 divisions? Because denominator is 4, that's it. So between 0 and minus 1, 0 and plus 1, if I divide the number into 4 equal parts, so first part, second part, third part, fourth part. First, second, third, fourth. Okay, see, first, second, third, and this is fourth. Okay, so 0 to 1 by 4, 1 part, 2 by 4, 2 part, 3 by 4. So we have to mark what here? 1 by 4. So this and minus 5 by 4. 5 by 4 will be, again we have to stretch it. This is nothing but minus 4 by 4. Minus 4 by 4 will give us what? Minus 1. This will be minus 5 by 4. This we have to mark. That's it. Okay. We'll keep on stretching the number lines until we find our number. That's it. Chalo. Next, compare. Let's compare number 2 and number 5. So number 2, as we can see, this has negative, this has positive. So positive will always be greater, right? So this is greater than 7 by 2. Here 3 by 4 and 0. We know 3 by 4 is greater than 0. So 3 by 4 is greater than 0. That's it. This comparison is very easy. Let's go the next portion. This is the solutions. Insert the rational numbers between these. Okay. This you need to put your head into it and understand what I'm doing. Okay. See, 5 by 7, I'm doing this. So 5 by 7 and 7 by 9. Average of these two is what? Half of 5 by 7 plus 7 by 9, which is equal to half. 7 9 63, 7 9s are this, so 9 5s are 45 plus 9 7s are 7 7s are 49. Okay, so 9 5 14 1 8 94 by 63 into 2 63. This is, so 2 and this gets cancelled out, so 47. Okay, so first is 5 by 7, 47 by 63 and 7 by 9. Okay, first number we have found out. Now time for the second number. Similarly, half of these two, half of 5 by 7 plus 47 by 63. Let's find out. So half into 63 LCM, 7 nines are, this is 45 plus 47. Okay, 45 47 is 12, 1 8 9, 92 by 63 into half, so 246. This is 46 by 63. Similarly here, as we can see, 46 47, so this will be 48 by 63 only, so no need to calculate it. Okay, sometimes try to use common sense as well. Okay, if you are not getting this, if you want something else, let's find it out. No, so half 47 by 63 plus 7 by 9. 63, 47, 49, half into, so half into 63, 9761896, 48 by 63. Okay, so we have found out three rational numbers between 5 by 7 and 7 by 9. Okay, I hope you understood this. I did nothing, I just averaged. First averaging 5 by 7, 7 by 9, add kiya. After adding, we had just divided by 2. Same, we have found out the middle number now. Middle number se now we are averaging first and the middle number. Answer found out. Again, middle number with the last number. Average, answer found out. Okay, it is that easy. Okay. Now addition of rational numbers. Okay, addition of rational numbers is absolutely same with addition of fractions. If you know addition of fractions, you know addition of rational numbers. Let's head on straight with the sums. Subtraction same as fractions. Okay, so this particular videos, I think you are already very much used to addition of fractions and addition, subtraction of fraction, multiplication and division of fractions. If you know that, you know how to do for rational numbers as well. Okay, see, in all of this, in the first and second one, as the denominators are the same, we can say that the LCM is 5. So minus 2 plus 3 minus 1 minus 3 plus 3 by 5, 0 by 5, answer is 0. First one, answer is 0. Okay, let's start this. Second one, 9 LCM, minus 9 minus 8 minus 2 minus 10 plus 4 minus 6 by 9, 3, 2 by 3, so this is minus 2 by 3. Done. Second one. Now third one, let's find out. 8 16 24. 8 16 24. Okay, let's start off with 8 only. 8 ones are 8, 8 twos are 8 threes are. So this is 6, 6 eights are what? 48. So 48 LCM, so minus 2, so minus 10 plus minus 6 plus 16 threes are, so 9. Okay, minus 16 plus 9 by 48, 9, 10, 11, 12, 13, 14, 15, 16, minus 7 by 48. Answer for this. Okay, now let us do for this one. As we know, denominator here is going to be 1, so LCM is 15. So 15 into minus 2, minus 30, 5 3, so 3 2s are 6, plus it's already given 15 minus 2, so minus 32 plus 6 by 15 minus 6, 636 minus 26 by 15. Done. Last one, 8 16 12. Let's find out 8 16 12. As I can see, 4 is the minimum, 2 4 3, again 2 is there, so 1 3, sorry, 4 4 2, this is 3, 1 2 3, this is 6, this is 8, 8 6 are again 48, the LCM is again 48, 12 fours are, so minus 44, 16 threes are plus 15, 18 6 are minus 18. Okay, so let's add this minus 44 and minus, so this will be 12 1 5 6 62 plus 15 divided by 48. Okay, so 62 and 15 minus, let's do it, 62 minus 15, 1 7 5 47, so minus 47 by 48 is the answer for the last one. Okay, chalo. First one. Okay, now what should be added? This type of sums are very important. Okay, this type of sums are very important. Let's do this as fast as possible. So the sum of two rational numbers is 4 minus 4. If one of them is minus 13 by 12, find the other. So minus 13 by 12 plus, I don't know what that is, will give us minus 4. That's it. So x is equal to minus 4 plus 13 by 12, which will give us 12 as LCM. So 12 fours are minus 48 plus 13, 5 minus 35 by 12. Okay, done. Second, what should be added to this to get this? So minus 3 by 32 plus, I don't know what, will give us 53 by 96. So x is equal to 53 by 96 plus 3 by 32, LCM 96. So 53 plus, this will be into 3, so 9, 9 element 12, 162 by 96. Okay, we can keep the answer like this, or 31 by 48. Okay, simplest form. Done with the second one. Third, what should be added to minus 3 by 20 to get to 9 by 20? Okay, so 2 9 by 20 is nothing but 20, 49 by 20. Okay, so x is going to be 3 by 20, 20, 49, 50, 51, 52, 26, 10, 13, 5. 13 by 5 should be added to this to get that. Okay, it is very easy. Whatever I am doing, try to do the sums first, and after that, see how am I solving the sums. Okay, these are the answers. Now multiplication, no point seeing the videos. Multiplicative inverse is nothing but reciprocal. This we all know, right? Division, same. Let's go ahead straight into the sums. Okay, let me do this and this. Okay, first one, 6 ones are 6, 7 into 18 multiplication, right? 6 threes are, answer is 21. This one, 14, 28, 29 into minus 7 to minus 1. So answer is minus 29 by 2. Okay. Now evaluation. Let's do this. Okay. Let's see. 12. 12 threes are 36. 36 plus 5, 41. 41 plus 3, 3 ones is 3, 4, 5 divided by 12. Oh, wow. A plus b divided by a minus b. Anyway, 36, 41 minus 3, 5 by 3. Okay. LCM 12. So 41 plus 3 fours are 3 fours are 4 into 5 is 20 divided by 12. 41 minus 20, 61 by 12 divided by 21 by 12. 61 by 12 into reciprocate. There you go with the answer, 61 by 12. Okay, chalo. This is the answer for the first one. Okay, we have done the last one. You can check, do it on your own. Okay, so this is it for this particular lecture. If you have any doubts, any issues, any problem, do let us know. I'll be like, if you want me to solve all the sums one by one, let me know. Okay, thank you for your time. Have a great day. Wish you all the best. Bye bye.